All right, guys. So today we're looking at the rest of your flow chart. So if you look on your flow chart, there's a column that says 4 terms. So you see it all the way to the right of your flow chart. We're going to go over that one first. And then all the way to the left top, there's 3 terms, or I'm sorry, 2 terms, but it's cubes. We're going to go over that one. Yeah, so we're going to go over both of those today. All right, these are the last ways of factoring that you will learn in this class. Okay? You're welcome. All right, so for 4 terms, factor by grouping, kind of the things I say to you constantly as we go through this. You'll group the first 2, group the last 2. You're going to factor out GCFs from each of those. When you do that, they should each have a common factor left over. The parenthesis will be the same. If it's not the same, you did it wrong. And then whatever the leftover factor is, that's kind of what you put in your other one. Because when we're factoring, it should still go down to 2 sets of parentheses, like we always do when we factor. So if you're looking at flowchart, we're looking all the way over here, 4 terms, and here it is left over. Okay, so group first 2, group last 2, factor GCF, common parenthesis, what's left goes down into here. All right, so this is what we're focusing on. All right, so number 11, notice there are 4 terms. This one's already set equal to 0 for us. So we're going to group the first 2 and group the last 2. Please include whatever that sign is with that. Don't just leave that kind of in between the parentheses. Include that in there. No, you would put it right. You would put it right back to where it was. So what's the GCF in just this first set? X squared. So if you take out an x squared, what's left? 1. Right, there's a 1 there. What's the GCF in the second set? Good, -3. If you take out a -3, what is left? Try again. Plus 1. -3 divided by -3 is a positive 1. And thank you, Don. Yeah, if you didn't put this 1 here at all, how would you ever distribute this back and get that? You couldn't. All right, so that was the first step, factoring out your GCFs. What's the next thing on the flow chart say? Common factor. Look. Look. Look, 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 look. They're the same. If they're not, you did it wrong. Okay? They should be the same. So my common factor is x plus 1. What's left over if I took out the common factor? X squared minus 3. Bam, factored. We have to solve. Pretty much. It's the next type of factoring that's the hard one. This one's not bad. Yeah.
Why didn't you teach us this before?
Because you've never had anything with 4 terms before? No. I've never given you anything with 4 terms before. Thank you, Sylvia. Did you hear what Sylvia just said? You have to have the bare minimum of 4 terms before you can do this method. And a maximum of 4 terms. You have to have 4 terms in order to do this method. If you don't have 4 terms, you can't do this. Everything you factored before today either had 2 terms, difference of squares, or 3 terms, and you set up your parentheses, options for A, options for C, and you did your whole thing, right? This is when I have 4 terms. You have to recognize the difference between these. So now we solve. So x plus 1 equals 0. X squared minus 3 equals 0. And we solve. So x equals -1. Here, add 3. Square root plus or minus radical 3. And we're done. Yeah. I'm not on 12 yet. That's it. 4 terms isn't bad. But that's later in the chapter. All right. So,
You're joking with us. You're smiling. You're not getting 12 terms with us.
sure I could.
Yes, you can.
I could. I could. Yeah.
I feel
All
like
right.
you said
So number
that
12.
to see the look on our faces. I feel like if you think about it, really gonna do it.
I could. Guys, relax. Once you hit more than this, you end up grabbing the graphing calculator, and it helps you by looking at the graph. All right, so number 12. Set it equal to 0 first. Noah, did you set it equal to 0 first?
Oh, yeah, I did that.
Did you set it equal to 0 correctly?
Yes.
Okay.
So I got the first part. It's going to be 4 squared. We can take out.
Okay, group the first two. Group the last two. Include that sign with it.
Okay, sorry.
It's all right. So make sure step by step.
So I took out 4 squared.
Good. What'd you have left? Good. Here?
That one is the one I get.
It'd be a -1. What do you have left? +1. -1 divided by -1 is +1. All right. Do you have a common factor? X plus 1. And then if I take that away, what's left? Or x squared minus 1. How are we feeling about the factoring so far? Doing okay? Real quick, just a little side note, because I know it's going to show up at some point throughout all of this. Guys, eyes up here for just 1 second. On something like this, let's say it was just x plus 1 already. What would be the GCF on x plus 1? 1. Please take out the +1 here, because otherwise when I take this away here, I still need 2 terms to go over here. Does that make sense? So if there is no GCF, please at least take out a +1. It doesn't change anything, but it will happen at some point. Yeah. Right. I just need that other term so that when I go to write my factors, I need something there. Okay? So just be careful of that. All right, so set each one equal to 0. First one's easy. X equals, I say it's easy, and she says the wrong answer right off the bat. All right. So add 1, divide by 4, square root, top, bottom. So plus or minus 1/2. Right, it's too easy, right? It's not supposed to be that easy. Doing okay? Oh, like the actual number one? Oh, you meant like, I'm just going to miss all of those. I'm like, wait, what? All right. Yeah, once you guys go ahead and try number 13 on your own. All right, guys, so 13, set it equal to 0. All right, first two, last two, GCF. What's left? 2x plus what? 1, thank you. GCF? What's left? Common factor? Noah, did you have a 1 there?
Oh.
You had a.
How did I get this? How did I?
I don't know how you did that. I don't know. Set them equal to 0. So -1/2. X squared equals 9. Plus or minus 3.
I got it right.
Awesome.
How did
I don't know. Go ahead and try 14. Let's go through 14, and we'll take a real short brain break, real short, because then we got to make sure we have time to get in the rest of this, okay? All right, so it's already set equal to 0. First two, last two. GCF? What do I got? GCF? Notice it's a +5. x plus 2. Common factor. The reason I made sure I put the plus 5 is if I take this away, I want to make sure I don't forget when I put this here. It's x squared. That's fine. If that works for you, that's just the way I was trained to do it, so that's the way I always do it. Equals 0. I'll go step by step for this one, just make sure we're okay. So subtract 5, square root, plus or minus. Good. All right, questions about 4 terms? How easy will it be to recognize this process? Because remember, your quiz is going to be a jumble of all the factoring. It's got 4 terms. Count how many terms you got. Now, granted, set it equal to 0 and like put like terms together. If it still has 4 terms, then you know it's this method. No, we have the other type of factoring still. Yeah, so, yep. So next we're going to look at the cube stuff. All right, but we wanted to do a real quick brain break. Which guys? All right, so we're talking about cubes, which is to the 3rd power. So first, let's have a list of cubes so we actually know, we recognize what they are. We are in our notes. All right. What's 1 cubed? 1. Remember, cubed means you're multiplying it by itself 3 times. So 2 cubed is 8. 3 cubed? 3 squared is 9. 4 cubed is 64. 5 cubed? 6 cubed? 7 cubed? 8 cubed? I know most of them on by heart. 9 cubed? 10 cubed? Well, yes. I said get your calculator out. All right, guys, real quick, I want to make sure we're understanding where the buttons are on our calculator. To cube something, you have to hit the little caret button and then the 3. Oh, not a calculator. Yeah, you could. All right, but we're actually going to have to do the cubed roots of things, right? Because we had difference of squares where we took the square root of each term, right? Now we have difference of cubes, so we're going to take the cubed root. So, for example, I want you guys to make sure we know how to do this. If you can do the cubed root of 512. So in a regular plain calculator, you would have to type in, make sure we're listening here real quick because it's different in your calculator. You have to hit the 3. So if you're using like the red calculator, the blue one, like those, yes, that one. So hit 3, clear that. Second, caret, yeah, 3, second caret, yeah, see how that works? And then 512. Because what that's going to bring up is you get this 3, and then you get this little x here like that. You're telling it, I want not square root, I want the cubed root. So you're putting a 3 right there for cubed root. Right, if you put a 4 in front of it, it would take the 4th root of something. In the graphing calculators, it's a little different. You would have to hit, I believe it's under the math menu. Hit math. And then cubed root is actually an option in there. So choose cubed root, and then you could type in 512. The math button. Did you find it? Damon, did you get it? Okay.
On my thing, it's 5.
The X one, but this one actually has cubed root right on it. It's right here, option 4. Okay, so now that we know how that works, let's look at this pattern. And this is exactly what's on your flow chart, okay? Honestly, this factoring is more of memorizing the pattern than it is the math behind it, okay? You have to know the pattern. So we're talking about not only difference of cubes, but we also can do the sum of cubes. So I don't care if there's a plus sign or a minus sign in between my 2 numbers. Doesn't matter. Okay, so if you look at your flow chart, you have 2 terms, right? Below on your flow chart talks about difference of squares. And then above that is your cube stuff, which is all of this. So when we're doing that, I'm looking for something that has two terms, and it should be really easy to recognize because it has an x cubed in it. Okay? If you see two terms and there's a cubed on it, and there's no GCF to take that out, it's going to be your cubes. All right, so looking at the pattern, it's the same pattern whether it's sum or difference, okay, how we set this up. So you're going to have two numbers. They're both going to be cubed. So one of them will probably be an x cubed, or a number with it, and then the other one's going to be a number, and it's going to be one of your cubes. Okay? I know they're not as recognizable as the squares that we're used to doing, but we're talking cubes. That's why we have a list of them. So what we're going to do, no. So then right here, when we set this apart, you're taking the cubed root of both of these numbers in the first parenthesis. So I kind of broke it down right here for you. So if I'm looking here, cubed root of a cubed is just a. And the cubed root of b cubed is b. So these first numbers I'm plugging in here are the cubed roots. Okay? Then to fill in the second parenthesis, this is a little different. We actually have three terms in that second parenthesis. It's the only type of factoring, bless you, that it kind of breaks down that way, where you have two terms and then three. So you're going to square, multiply, square. And the numbers that I'm squaring, multiplying, and squaring are actually here. So once I take the cubed roots, I don't care about this anymore. I'm not even looking at it. I'm using this. So I'm going to take this first number, I'm going to square it. I'm going to multiply a times b. I'm going to multiply these two numbers to get here. And then I'm going to square the last one to put here. So square, multiply, square. Square, multiply, square. Take this first number and square it. Multiply the two numbers, and then square the last one. Square, multiply, square. So it goes over here. Noah. We'll go over it in just a minute, okay? We'll go over it. I haven't even talked about signs yet. Just hold that thought on signs. All right, as far as signs go, the plus, the minuses, and all of that stuff, use SOAP. Okay? If you remember you can remember SOAP, right? Always use SOAP. If you go to the bathroom, please always use SOAP. Don't reuse your toilet paper and always use SOAP. Okay? Did my name come up that you guys talk about that in my class? Oh, okay. All right, so anyway, SOAP has to do with your signs. The S stands for same sign. So when I'm factoring this, whatever this first sign is, I'm going to put the same sign in that first set of parentheses. Right? So that's same. The O stands for opposite. So the very next sign is going to be the opposite of whatever that one was. Opposite. And then the last AP stands for always positive. That last one is always a plus sign, no matter what. So same, opposite, always positive. So if this was a minus here, this would be a minus, and that would be a plus. Mm-hmm. Can I go through an example first? Let me go through the example. I'm not going to solve it yet. We're just going to practice factoring it. Okay? So again, I have to recognize two terms, and there's a cube. So I'm like, okay, is it my cube pattern? Is 27 a perfect cube? Is 8 a perfect cube? Yeah, look at your list. 27, 8. They're perfect cubes. They're on my list. So if I go to set this up, just like I always have done, I set up my parentheses. I'm going to fill in my signs before I do anything else, just like I always do when I factor. So same goes here. Opposite, always positive. So before I do anything else, I'm always going to fill my signs in. Okay? So next, let's actually do the math of filling stuff in. The math. So I'm going to take the cubed roots to fill into the first spot. So the cubed root of 27x cubed is 3x. And the cubed root of 8 is just 2. Now I know with squares, it's like we filled it in the first one, we filled it in the second, like it doesn't work that way with cubes. All right, take the cubed roots, put them in the first one. Now we have to square, multiply, square. So what's 3x times 3x? 9x squared. Right, I squared it. multiply the two together. What's 3x times 2? Notice I didn't even look at what the signs were because I already filled my signs in. I don't care. And then square this one, 4. That's what I just said. I didn't even look at my signs because I already filled them in by using SOAP. Yeah, that's why I filled my signs in first. That way I don't mess that up. Yeah, try. We'll have to solve, but we'll get there in a minute. I just want to make sure we're okay with the factoring process.
So you square the first one, multiply the other.
Yeah, it's a matter of recognizing the pattern. Set up SOAP, square, multiply. Yep, I took the cube roots of them.
No, actually, I read it on so sad.
Yeah, sorry. Okay.
No, that wasn't what I was saying.
Okay.
Oh.
I'm listening. Oh, a great question. All right. All right, so again, everything that I just showed you is on your flow chart right here. Okay, it's on there. All right, so now let's actually get into one and we're going to solve this. Okay, so as always, set them equal to 0, which we did. All right, I'm looking at this. There's two terms. Are they cubes? I have an x cubed, and is 27 a perfect cube? Is it on your list? Yeah, it is. So let's set up our parentheses. Remember that second parenthesis is a little longer because it's got 3 terms in it. Same, opposite, always positive. So again, this factoring is really, it's the pattern. It's not one I can kind of guess and check my way through. It's a pattern you have to memorize. What's the cubed root of x cubed? And the cubed root of 27? 3. All right, so there's the first step. I want to make sure we're good before I move on. All I did was take the cubed root of both of them. Questions there? You guys are already moving on, aren't you? All right, so then we're going to square, multiply, square. Yes. So you squared x squared is x squared. Multiply them, which is 3x. And square the last one, which is 9. Good. All right, so now I'm down, it's factored. Set them equal to 0 and we solve. Let's talk. So the first one here, what does x equal here? Now, here, normally it's still an x squared. Noah? Noah?
Okay, so you have to subtract the 9, then you have to divide by the negative.
I swear, and this class could be a sitcom.
Then you have
We have the jokes, and all of a sudden you have Noah for one of those skits. I got this. Do you really?
okay, so you have to
I'm gonna stop you right there. I'm gonna stop you right there. Justin? Okay. I'm sorry, Noah. When you solve an x squared, Noah, were you saying subtract 9? If I didn't have a b term, I would say you're right. But I got a b term, so I can't. So Justin said, can I factor this? It doesn't factor. I have to use the quadratic formula. But guys, hold on, time out. I want to make sure you understand something very clearly. It will never factor further. Ever. You always have to use quadratic formula on that second part. But I've taken away the, can I factor this further? Playing around with it. It ain't going to work. Ever. You have to use quadratic formula. So, yeah, this one will always be nice. And then you have to use quadratic formula. Always. So, negative b plus or minus square root b squared. That's 4 times a times c all over 2 times a. So 3 plus or minus radical, what do we get under there? Negative 27 all over 2. Yeah. You could check the discriminant here, but since your discriminant is a negative, you know that it doesn't factor. But yeah, I can guarantee you it will never factor. Ever. Ever, ever, ever. 3i radical 3 is correct. All over 2. And that's as far as I can go. So this one, It's not bad if you can remember the pattern. The problem is the students that don't memorize the pattern of it and they try to do the whole guess and check thing, it ain't never going to happen.
So it's always.
Oh, those are those students who don't try to memorize anything. Like, yeah, I can play around with the numbers and get it to work. No, you can't. Yeah. So let's look at the next one. No. Okay. Okay, take a minute, look at the next one. There are two terms, right? I need you to start recognizing things on these. There's two terms. Okay, so I know it's either cubes or squares. Which one is it? Cubes, because there's an x cubed. Is 128 and 1458, are those on your list of cubes? There's a GCF in there.
Is it 128?
No. It's 2. Hang with me. Be all right. So let's take out a 2. So 64x cubed minus 729. Are 64 and 729 on your list?
Yes.
Yes. Now, guys, here's what I would like you to do. Before the quiz on Friday, I will let you use your pink flowchart on your quiz. You may write your list of cubes on your pink flowchart. That is the only thing you're allowed to put on there. No other writing should be on that thing. Because you lost your flowchart? Maybe you should get another flowchart. I'll have to make you a copy of it. All right, so guys, you can write your list of cubes, okay, on your flowchart. That's fine. All right, so here we go. So now we know these are on there. So let's go ahead and set up our parentheses. And let's fill in our signs. So same, opposite, always positive. Questions on the signs? Good, good, good. So now we have to fill in the cubed roots of both of those. What's the cubed root of 64x cubed? 4x. Cubed root of 729. Now again, don't get yourself wrapped up in the difference of squares where we fill in 1 plus, 1 minus, and I'm done, right? It's not like that. We have to do that other pattern here. So 16x squared. You got to square 4 squared. So that's 16x squared. Good. Multiply those together. It's 36x. 81. And we square. Will that factor further? No, never will. So I know right away one of my answers, though. 0 is not an answer. Is there an x out here? There's no x. So do I need this too? No, I don't. He doesn't give me an answer. Good. Positive 9/4. I got that one. You're allowed to lose him here. There's no x with him. I don't need him. Kick him to the curb. That's right. Get rid of him. All right. So here we go. So I have to set up quadratic formula. Negative b. These numbers get a little big. Plus or minus square root b squared minus 4 times a times c all over 2 times a. Yeah, the numbers got a little big here. Yikes. What did we get under there, guys?
Over 32.
Negative 3,000 what? What'd you say? 3,000? What'd you say, Quincy? 888? That? Okay. Over 32? And everybody's going, ah, crap, that's a really big factor tree. Right? There is. I know what the answer is right now. I can do it by looking at it. Bet me.
She says that. Do it.
Bet me.
Bad. Bad.
Bad wall.
I don't think that'd be a good bet considering she looks pretty confident. Don't need to
Show it. You can show him it.
Again, Cole's pretty confident.
Yeah, I'm pretty confident you drop, but you didn't drop.
I think you
But that's me.
then we have to simplify. How on earth would I have known that without doing any other math?
Boom, roasted.
I love that you think I'm that smart. I'm really not. No? You know me, I don't memorize the answers.
It has to be.
So, it is. There's a pattern.
You gotta count GCF.
Look at the one we just did. Look at the numbers. Look at the radical is always 3.
What?
Look at the other numbers.
It's the same.
It's the same.
What?
See, these are the same? See, there's an I? See, it's a radical 3? Same? There's an I and there's a radical 3. See it? Told you I could do that in my head.
So pretty much when you get the first answer, you pretty much have the second.
Now, do I expect you to memorize that and be able to just kind of spit that out? If you remember it, more power to you. I just saved you a ton of time. Otherwise, could you still do your factor tree on that and get it? But could you? You could. You could. All right, well, let's simplify this. I can divide them all by... Simplify that. Oh, thanks.
I don't think the next week not till tomorrow.
Oh, you're right. Thank you. Oh, he gets my mail for me every day. That's what he's doing. Oh, it don't matter. I can still simplify.
But you can't multiply.
I can divide them all by what?
4.
So I get negative 9 plus or minus 9i, radical 3 all over 8.
That makes total sense. So you don't have to do.
Yeah, let's do one on your own.
That 888.
Oh, this one's really easy. You guys want to do a really easy one or do you want to try a little harder one? Okay, number 17 on your own. This is a really easy one. All right, let's go over this last one that we have time for today. Let's see how we do. All right, so number 17. It's already set equal to 0. There's no GCF. Hopefully you recognize there's 2 terms and it's got cubes on it. Set up your parentheses. My signs, follow your SOAP. Same, opposite, always positive. Cubed root of 8x cubed. Thanks for the help there. That's 2x. You guys alive? Cubed root of 1. 1. Square multiply square. So 4x squared. 2x 1. So there it is factored. Okay? From there we have to set them equal to 0 and solve. So this one is negative 1/2. This one will never factor, so we have to use quadratic formula. So negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Guys, hang with me, please. So 2 plus or minus, it's going to be 2i radical 3, not even looking at it, over 8. And then we have to simplify. Yes, it would. Noah?